Hi everyone, welcome to this evening of a live problem session. My name is John Paul Raj. I'm super excited, super nervous, super thrilled about this live stream. This is my first ever live problem solving session. Okay, so you've got to help me out. I'm going to keep an eye on the chat. So first of all, if you're joining me live, please let me know where you're joining me from. Okay, and that'll help all of us get to know, because you know what, if it was a Zoom session, you know, you can see who all are there and the participants, and this way at least you'll get to know who all are there, right? So maybe just say hello, my name is blah blah blah, and where you're joining us from, so you will know who else is there. Okay, and having said that, I want to let you all know that this is going to be a problem solving session on paper 6 for IGCSE 0607 International Mathematics. Okay, but before we go in, I wanted to offer some tips, some advice about the general layout of this paper, you know, and how to approach this paper, because many times, you know, everyone has their own opinion about it, but this is from my own experience. I want to share something about paper 6 0607 International Math. Okay, first of all, let's pay attention to this one. This is a paper, you can see it's May June 2021. The paper is 1 hour 40 minutes. All right, and there are two parts to this paper. There's investigation part and there's a modeling part. Today in this particular session, we are just going to solve this investigation part only. All right, we won't get enough time. Perhaps the next week or some other stream, we are going to do the modeling for this particular paper. But before we go on to that, some more things about this particular paper. So you got 1 hour 40 minutes in total, but this paper, if you actually pay attention to every little thing that's written, they have said something very important here. They've said you are advised to spend no more than 15 minutes on this part. And they say the same thing at the start of the modeling part. Okay, now this advice is real, and I'll tell you why. Because the way the questions, the sub questions for each part are laid out, it is in what do you call it, gradual levels of complexity. Okay, I just happen to see the chat here. Okay, maybe let me just see whether I can just highlight some chats here. There is someone is an excited straight from Timbuktu. Okay, but I don't even know how to get this chats going on here. This is the first time, so how do I get this thing going? All right, a slight distraction, but once I figure that thing out, I'll try and see how to get the chat, because there is an option apparently you can, you know, display the chat. I'm just trying to see how that works. So here we go. I have the chat on and the chat is off, but now I get here, and if I say, can I see the chat? There you go. All right, I figured it out. Great. And we've got another chat here from Excited State, from Timbuktu. Great. I'm sure that this is a nice joke. And there is my good friend Jalaj. Thank you so much for joining all of us. And let's continue. Okay. So I was saying that each of the questions increase with complexity. So what happens is, as you move on towards the end of each section, there's like 5 or 6 questions on each part. The level of difficulty will increase. That means the time taken to process those questions is going to be important. Okay, so if you're stuck somewhere on part 4 and part 5, if there's like 5 questions to each part, then the advice, not just my advice, but also CIE has advised, move to the next section, because the first few questions of the second part will be easier, right? So you might as well get those points for that, right? So why just waste time in that? That advice is real, that advice is important. So keep that in mind as you're doing a paper, something like this. Okay, so your advice, no more than 15 minutes, 50 on each part. Then obviously if you have time, you can come back to that. Okay, so here we go. The next thing that I want to point out is this paper, more than any other paper, yes, in paper 2, paper 4, you got to show your working, but in this particular paper, look at this instruction given here. In this paper, you will be awarded marks for providing full reasons, examples. You have to give the example. It's not the examples in the paper. You have to give examples. For what? For providing full reasons, examples, and steps in your working to communicate. So more than anything, I think this paper is a lot about communication. And for some of you who've seen the marking scheme, this paper, there's the marks allotted is for communicating, but communicating with right mathematical vocabulary, the notations used, graphs. If you're using the graphing calculator, we'll come to that. Okay, if you're using your graphing calculator, make sure that you make a rough sketch, but indicate all the important features. So another tip to be able to be ready for this paper is you should you need to know your graphing calculator. Okay, so make your graphing calculator your best friend and get to know your graphing calculator. And there's another thing that's mentioned here. You may use a tracing paper. Yeah, you can use a tracing paper also. So if anyone tells you, that you can't use your tracing paper, any tools that you can bring. So I would say even get a geometrical box. Okay, because different methods can be used. And often students tell me that how should you prepare for this paper? Paper 6 is all about investigation and modeling, that. Well, this is not like the typical exams where you can prepare by, like it's a test on quadratic equations, so you study for quadratic equations, or it's a test on functions, so you study for functions. But this is all about investigation. And so the way I compare it is I think of it as a crime scene, literally like a crime scene. And in this paper, everything is included. Whatever you need to solve this crime, this mystery, this investigation, everything is included. So if you have watched shows of investigation, then it's something like this. A detective goes and asks a question to someone, and then he goes to someone else and he says, okay, that person is probably not the suspect. He goes to the other person, then he goes to the third person, and then he goes to some other person. And so there are some chats going. I've just ignored that, but yes, please keep it civil. Okay, I don't know, because I've allowed everyone to talk. This is a community, so let's I don't know what the chat was about, but okay, that's all right. Okay, just remember this is a learning time for everyone. So, but at the same time, let's learn to be good citizens. That's not just a global citizen as far as nationality is concerned, but also now this is a world of social networking. So even how good how good a citizen we are even in the social world. Okay, so I'll talk about that Rubik's Cube later on, excited state, but not today. Okay, today we are talking about this thing. So I was talking about this investigation. So you ask a question to someone and you go back to someone else, and then you go back to someone else, and then probably you realize that, oh, let me ask that question to that first person again. So you go back to that first person and ask the questions again from that person. So in the same way, when you're looking at a paper like this, how I am drawing the parallel is that you will have to do a lot of going back and forth. So just because you finish question number 1, in a typical paper, you finish question number 1 and you go to 2 and then 3 and you move on and move on. But in this particular, especially because it's investigation and modeling, you may need to go back. You may need to go back and look at the other work and utilize all those things. And that is what I mean when I say that everything that you require for able to solving a paper like this successfully, it's available there. They even give the formula sheet. Okay, so go prepared with your tools, everything that's required. A few things about this paper. Here it says 50 minutes before 2020. So if you are trying to solve some questions, paper 6 questions before 2020, it was 45 minutes per part. Okay, so don't get freaked out when you're trying to solve a previous paper prior to 2020. So that's 45 minutes given there, and also these marks out here, this is 30 marks given here. I think before 2020 it was 25 marks. So the total marks actually prior to 2020 it was 15 marks, and the total time was also 1 hour 30 minutes. Okay, so now they've changed that, but the level of questions, the kind of questions are all the same. Okay, so here we go on with this paper. What else do I want to say? So yeah, the other thing I also want to say is that, like every other paper, I think more than any other paper, this particular paper, when you're solving this paper, you need to have a really clear mind, so not to get cluttered and not to get distracted when you see, comments that probably, try to distract you. So just leave those aside. But just before the paper, the night before the paper, get a good night's rest. Okay, your mind needs to be clear. But like I said, because I said that this is an investigation, so only when you have a nice, clear, calm mind, you'll be able to follow through all the clues given in the paper to be successful in that. Okay, having said that, let's look at this question. This is investigation 2021, summer 2021. Okay, it's talking about the nearest neighbors. It says this investigation is about the distances between points on square and triangular grids. As I said earlier, this paper tests our communication. So at the same time, you need to really clearly see what is the paper trying to communicate. What is the question? What are they trying to communicate? So even as you're reading the question, it's a good habit to even underline keywords, words that stand out to you. So just, with a pencil, whatever, just, underline the keywords. This investigation is about the distances between points on square and triangular grids. All points have integer coordinates. Every one of those words are important. So just, keep an eye on all those things. And here we look at the grid, and just don't bypass that and go to the next question. Take a look at it and, try and scan that and see what's there. So what do we see? We've got 4 points, given as circles, and yeah, and the coordinates of the points are there. Cool. Now let me go on. We say the point 0, 0 has 4 points closest to it. Okay, or 0, 0 is the origin, and those are the 4 points that are closest to it. Each point has a circle around it. Okay, that's how they've indicated. Maybe it's not in a color, so let me just highlight those points. That's the circle, that's the circle. If you have this question paper, maybe you should just take it along and solve it along with me. All right, so each point has a circle around it. The points have coordinates negative 1, 0. Negative 1, 0 is that point. 0, 1, 0, 1 is that point. 1, 0 is this point. 0, negative 1 is this point. Okay, so we've got those four points, and these 4 points they're saying are called the first nearest neighbors to that origin 0, 0. Okay, so they've defined something for us, and we've looked at it the way it is described on the graph. Okay, the points which are next closest to 0, 0 are its second nearest neighbors. So those are the first nearest neighbors. Those are coordinates of the points. The points which are next closest to 0, 0 are its second nearest neighbors. One of these points has coordinates 1, 1. One of these points has 1, 1. So 1, 1 is there. Okay, let me use another color maybe. Okay, 1, 1 is this point out here. Okay, and what can we say? Well, these are about 1, and that should be the diagonal, right? Okay, like a Pythagoras theorem, right angle triangle. So it's about root 2 from there, and you can see that find the coordinates of the other second coordinates, the second nearest neighbors, the other second nearest neighbors. So if you look at that same idea, then with that same distance of root 2 from 0, 0, we've got this is 1 point, this is the third point, the fourth point, and each of those points are at a distance of the same similar distance. Okay, it's root 2 from here, root 2 from here, root 2 from here. Okay, if you use the Pythagoras theorem, the idea, you know that the distance of those points from the origin is going to be square root of 2. So when we just indicate those coordinates of those points, they've given 1, 1, so we can write down the responses for the other ones are 1, negative 1, 1, negative 1, comma negative 1, negative 1, comma negative 1, 1. Okay, cool. All right. Another difference from the earlier years is this. Okay, in the papers prior to 2020, you were not given these sub points. Okay, so only after 2020, when you look at those earlier papers, also you can see that those points are not mentioned. So only from 2020 they have mentioned all these sub points also. I just want to take a look at these things. I like your hairstyle, Mr. Raj. Thank you so much. There is no hair. Okay. I think I've seen you before on the last one. Really? Okay. These are really funny remarks. Maybe just to say, all right, what, you guys are on a social platform. Okay, just keep in mind that also. Thank you so much for being part of this thing. I don't want to ban you guys just for saying these things. You're good people. I know that. Okay, we are here to learn. Maybe you can learn something about being a responsible social citizen also. Okay, how you conduct ourselves, how you conduct yourselves in a social platform, something like this. But thank you for being here. The distance from 0, 0 to its first nearest neighbor is 1. The distance from 0, 0 to its first nearest neighbor is 1. Okay, so that's how they've defined the first nearest neighbor. That's the distance from 0. That's 1. Okay, so I think they're asking for the second. Show that the distance from 0, 0 to 1, 1, a second nearest neighbor, is root 2. Well, that's the same thing that we talked about, right? It's using the Pythagoras theorem. So indicate, maybe what you can do is that you can even label it as a triangle. So you can label it as A, B, and C, and you can say that A has those coordinates 1, 1, and then you can say in triangle, what did I say? Is it AOC? Yeah, I said AOB. All right, so in triangle AOB, using Pythagoras theorem, you can say 1 square plus 1 square is going to be equal to 2, which means that OA, which is going to be that distance. Okay, the distance is distance from 0, 0 to 1, 1 is going to be equal to square root of 2. Okay, so that's clear from Pythagoras theorem. So make sure that you have communicated that also correctly. Now the table shows information about the nth nearest neighbors, and this is where it starts getting generalized. Okay, so they're using particular examples here. Okay, particular coordinates of points, and then there's some generalization going on here. The table shows information about the nth nearest neighbors 200 for values of n from 1 to 11, okay, and there are some gaps here. I think we need to fill that. D is the distance from 0 to the nearest neighbor, so that's D, and then they've given D square. N is talking about when n is 1 is the first nearest neighbor, n equals 2 is the second nearest neighbor, and so on and so forth up till 11. They've given a lot of data for us, and we need to find out the number of the nth nearest neighbors. Okay, there's lots of stuff, but we need to figure out. So let's look at the second nearest neighbor. Second nearest neighbor is what we have plotted, and we can see that there's 1, 2, 3, 4, 4 of those, so we can fill that in quickly. So there's 4. And for the third nearest neighbor, they've given d square. So if they've given d square, we can just say d should be the square root of 4, that should be 2. D being a distance, obviously it has to be positive. And likewise for the fourth nearest neighbor, the distance is 5. D square is 5, sorry. So the distance should be root of 5. And then we have to fill these things. For the third nearest neighbor, remember the distance is 2. Third nearest neighbor, the distance is 2. So I don't think we've done that, so we need to go back to this. The distance is 2. So when we are trying to find that, let me use another color now. The distance is 2 from the origin, so that point is at a distance of 2. That point is at a distance of 2. That point is at a distance of 2. And that point is at a distance from the origin. Okay, so there's 4 such points, 4 neighbors. So we write 4 here. Okay, now the fourth nearest neighbor at a distance of under root of 5. Under root of 5, remember we use Pythagoras theorem, the idea of Pythagoras theorem. So it's obviously a combination of that. So under root of 5 will be, you want 1 square and 2 square, right? So 1 and 2, that kind of thing. So let's mark those points with red perhaps. 1 and 2, that will be 1 point. If that's 1 point, this point will also work. Then 2 and 1 will also work. This will work, and this will also work to a negative 1. And then using symmetry, we can say that this point is also going to work. This point will also work, negative 2 comma 1, negative 1 comma 2. And this point will also work, and this point will also work. So we got 1, 2, 3, 4, 5, 6, 7, 8 points. So there are 8 nearest neighbors. All right, so that was the first part to complete the table. The question part B says, is d squared directly proportional to n? Show how you decide. You got to actually I think, okay, a square plus b square. Thank you so much, Excited State. Is d squared directly proportional to n? Okay, let's just put this question forward. Okay, I don't know whether you can. Is it proportional? What would you say? Let's just wait for a minute. Is d squared? Let's just wait for a comment. What do you guys think? Is d squared directly proportional to n? And how would you decide? What is the reason that you'd give? Anyone? Is d square proportional to n? How would you decide that? Feel free to put it on the chat, please. And then there was silence. Wow. Well, are you saying that it is proportional? It says d square is directly proportional to n. Oh, I said something else. I showed something else. Sorry about that. That's what I wanted to show. Are you saying that it is d square? Remember, we're comparing d square and n. Okay, when a graph, let me just show some work here. Okay, so when you have a graph and you've got something along the y-axis and something along the x-axis, when something is directly proportional, as values of x increase, values of y will also increase. That's the idea of saying directly proportional. Okay, one increases, the other one also increases. The rate at which it increases might be different. X's might increase differently. So one way to show direct proportional is just plot those points on your graph, okay, and see whether you get a straight line kind of a behavior. All right, so as x approaches, will the y approach, y also increase. So in this case, we are looking at something like, if you have a d squared there, and I think they asked d squared and n. Okay, so if you can do that, that's one way to do. Also, the other way to show whether they are directly proportional is taking the ratio of corresponding terms. Okay, so let's take the ratio of corresponding terms. So when I do that for the first few terms, 1 over 1. Okay, so let's just say we are comparing d square, the ratio of d square over n. For the first comparison, that's 1 over 1. Well, okay, the second one is 2 over 2. That's equal, right? But when you look at the next one, it is 4 over 3. The ratio of the corresponding terms must be equal. The same thing happens when you look at the next term. Okay, you've got 8 over 5. So if it were directly proportional, okay, if d square was supposed to be directly proportional to n, then the ratio of those corresponding terms must be equal, and that's what's going to give us this kind of a graph. Okay, so if it's not, let's vote red out. I have no idea what these guys are saying. Let's vote red out. Seriously? I don't know. Okay, and someone has named themselves with me. Anyway, thank you for being here. But just be careful what you're saying on these things. I'm just here to make sure that we can solve this paper with fun. And so it's good to have fun, but also let's keep in mind what we're having fun about. Okay, so I don't want to get distracted by this kind of stuff, but just be involved in the problem solving. Enjoy the problem solving. Why don't you do that? Okay, so here we go. D square is not directly, so I'm just going to say therefore d square is not directly proportional to n, because if it had been, then the ratio of those corresponding terms, all the terms, okay, not just for the first two values, throughout it should be the same. You can either show it with these the ratio terms, or you can even plot the graph and make a little sketch and show that it's not actually a straight line. That will also help to verify and make the claim that d square is not directly proportional to n. Okay, moving on. The 12th nearest neighbors, they've given us values only up to 11. Okay, clever of them. The 12th nearest neighbors to 0, 0 are at a distance h. So the distance is h, where h square is equal to 20. Okay, find all coordinates of those. Find the coordinates of all these nearest neighbors. So earlier we actually plotted those points, right? And it'll take a long time for us to try and plot all those kind of stuff. So we can't use that approach, but we can use this relation now. h square is the same thing as a d square. Okay, they've just used h now. h square is equal to 20. So we want to find pairs of coordinates that using Pythagoras theorem will have the sum of the squares as 20. So let's do that. Okay, so we'll say let AB be the coordinates of the 12th nearest neighbor. So if that's true, then we know that using Pythagoras theorem, that a square plus b square must be equal to 20. Okay, and we already said that those are coordinates, so they must be integers, right? So because of that, let's try it out. Okay, so if you have a is equal to 1, if you just take a is equal to 1, what's going to happen? Then you'll have 1 square plus something, a square number, should be equal to 20. But 1 square is 1, and 1 plus 19 is going to give you 20. So that's not going to work out, right? That's not going to work out. So if you take the next integer, if you say 2 square plus some other square is equal to 20, and there you say, 2 square is 4, 4 plus 16, 4 plus 16 is 20, right? And 16 is actually 4 square, right? So 2 square plus 4 square is 20, and therefore you can say 2 comma 4 will be one such neighbor. And if 2 comma 4 is one neighbor, then we know that because they are squares, negative 2 comma 4 is also going to be one of the neighbors. Also 2 comma negative 4 is going to be one of the neighbors. We're talking the 12th neighbors, right? And then also negative 2 comma negative 4. These will be neighbors. Now let me see on the chat. Any other pairs? Just by looking at it, let me see in the chat. This is a doubt. Could you please solve it for me? We'll do it later, Jonathan. Okay, but right now let's just focus on this one. Okay, what is supposed to be in the boxes? Those are blanks. That's just as a guess. So we are saying 1 square plus what would give me that? Okay, so I just said 1 square plus a mystery number, an unknown number. What should give me that? And it's that way. I'm just saying that it's not going to work out with 19, because 1 plus 19 will give me 20, but 19 is not going to be a square number, so we opted that out. But 2 square works with a 16, and 16 is a square of 4. Make sense? That's how I made that boxes, simplifying it. Cool? Okay, now using these four points, can you find out, can someone put on the chat what could be other possibilities? 1 comma 3. 1 comma 3. Will that add up to 20? Let's check. 1 square is, okay, 3 square, but 1 square is 1 and 3 square is 9, no? That's not adding up to 20. 6 comma 9. 3. Wow. Okay, 4 comma 2. An extra digit there. 4 comma 2 will work. Okay, so there's another set. So 4 comma 2 will work because again you can see 4 square plus 2 square, right? So that's going to work. So 4 square plus 2 square, just interchanging, right? That's because of symmetry. We already saw something to do with symmetry here, right? So if these points are here, you see something symmetric even there, and that's because it's a rectangular grid. All right, so here we go. If 4 comma 2 will work because 4 square plus 2 square will still add up to 20, then we know that negative 4 comma 2 will work, then 4 comma negative 2 is going to work, and negative 4 comma negative 2 will also work. So you've got those things. Anything else will work? Will anything else will work? Square root of 19, we're looking at for integer, and remember these are coordinates. Excited state? Root of 19 will not work because we're just talking about in a rectangular system, okay? So those are integer values now, okay? Any other points will work? Truly excited. Negative 1 multiplied negative I divided by the constant pi r cubed root 3. That's really in an excited state, okay? That doesn't apply to this question right now, okay? So root 19 is an integer, but more accurate. Yeah, we'll discuss that later, maybe some other day. Why is root 19 an integer, you think, and why it's not then present on the coordinate system? Okay, can you say that? Apart from this theoretic idea, root 19, why it's not one of those pairs of coordinates, why it's not used? Because in a coordinate system, everything has to be equal, right? So if you're using root 19, then it has to be all multiples of root 19. Okay, if you're using that system, that as a base, but it's not that base, it's units of 1, if that's clear. Okay, so it's a square and it's units of 1. That is why root 19. So if you're saying that root 19 should be possible, then everything should be a unit. I mean, you're taking with units of root 19, but it's not so in this case. So we can't use root 19. Helps? Some other day, okay? Some other day, okay? He's asking me to solve the Rubik's Cube, okay? And you know, many people ask me, why is the Rubik's Cube here? Actually, the Rubik's Cube is here just for color, right? Just like this Nescafe is here just for color, all right? And actually, that's not even coffee, that's just hot water, all right? So let's go on. We'll solve that cubic some other day. Maybe you can call you, okay, one day to help me solve that thing. Number 4, let's look at this thing. Here is a rectangular pattern of points on a square grid. All right, so what are the key words that stand out? It's a rectangular pattern, square grid, and what do we see here? We see there are points labeled as circles, and there are these squares here, and there are triangles. Let's read how they said. Nearest neighbor distances can be found for these points. The two first nearest neighbors to 0, 0 have circles around them. Okay, now two first nearest neighbors. Okay, so there's only 2. Now, this is a different scenario from the first scenario. Why? Because in the first scenario, we had 4 first nearest neighbors. We had 4 such points, right? In this case, they're just saying 2. So it's a different scenario. They just said it's a pair of first nearest neighbors, just 2 of them. It's a different scenario, therefore. The 4 second nearest neighbors to 0, 0 have squares around them. So these are the first nearest neighbors. These are the second. I'm just going to put 2 here. These are the, sorry, that's triangles, sorry. This is the squares. This is the second one. 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 So there are 4 of them there, and the 4 third. So that's the third nearest neighbors have triangles. Okay. So this is the third one, third one, third one, and third one. Clear? If you can see this. Okay. I don't know. I'm just getting distracted by that. Here we go. So it says complete this table. nearest neighbor, first, second, third, fourth, and they've given 5, 6, 7. We need to identify the fourth, which has, we need to identify the d square, okay, the square of the distance and the number of the nearest neighbors. Let's look at that, okay, let's try and count, okay. D squared for the first one is 1, and you can clearly see, because d squared is the distance from the origin, if that's 1, then the square of the distance is 1, okay. So that way they have counted the distance, and you have got 2 such, okay, that's good. For the second one, d square is 4, that means d must be 2. So this is how they've counted the distance, okay. So 2 units here, 2 units here, and 4 such, which means you got d square is 5 for the third one. All right, that's again using the same Pythagoras rule. So that's, you know, 2 square plus 1 square giving you that one. And now you need to find out the fourth. Okay, what's the d square for that? Now, because it's a rectangular pattern, I think the hint is here. It's a rectangular pattern. The fourth must be, you know, completing that pattern, fourth must be here, the fourth nearest neighbors. Okay, if I have to indicate that in green and write 4, that's where the fourth nearest neighbors will be. Okay, and using the Pythagoras theorem idea, the distance, this is 2 square and 2 square, so that's 4 plus 4, that distance d is going to be 8. All right, meaning square root of 8 is the distance, but d square is going to be 8. Okay, so that's going to be 8, and we've got how many such points? We've got 4, right? So that's 1, 2, 3, 4. Clear, everyone? Yeah? All right. Pretend to be a teacher. You are not teacher, mental mathematician, but there is unknowable truth that you can never understand. Okay. Oh my God, this is getting a little crazy. I'm so sorry. Okay. I'm sorry. There's some things are fine, but you know, some things are a little off. I'm really sorry about that, and maybe, you know, it's just really sorry. I didn't expect this thing. Okay, I did not expect this thing. I apologize to anyone else who's here, but I don't like to ban. I don't want to ban people. But when things get a little out of hand, then I think, yeah, this is just. Let's just focus on learning, okay? And it's also important, like I said, you know, to be responsible citizens, digital citizens also in the social media circle. So let's just be careful what we write, how we write. Fun is good, okay? But what we say, we can't take back, right? Especially when it's in this kind of a medium. So let's just be careful what we say and how we say, all right? Let's just not get distracted. Let's just focus on the task, okay? And this is my first ever live stream, okay? So great, welcome. Number 5, this is the last, is it the last part? It is not the last part. Okay, there's still some more to go. So let's just focus on this work now. This is a grid of points. Now this is a completely different scenario. This is a grid of points made from equilateral triangles of side 1. This is a grid of points made from equilateral triangles. So you can see that this is not the same rectangular grid, okay? And it's equilateral triangles of side 1. These points have coordinates as shown on the grid. So you can see that if they are equilateral triangles, then this angle here must be 60 degrees, right? So it's inclined, and all those lines parallel to the y-axis. This is the y-axis in this case, okay? It's inclined at 60 degrees to the horizontal x-axis, and each other, you know, line parallel to the x-axis, they form those triangular grids, and you can see those points there. Okay, so that's the grid of points made from equilateral triangles, and each of them is a unit 1. All right, these points have coordinates as shown in the grid below. So this particular point they've said is 2, 3, which means it's 2 units, you know, along the x and 2 units along the y, the same way as you'd read the rectangular coordinate system, but just that it's inclined. Okay, the y-axis is inclined at 60 degrees, and it's an equilateral triangle. Okay, grid made up of triangles. The circles show the first and second nearest neighbors, and this time circles. So those points out there, the nearest neighbors are indicated here. So the first nearest neighbors, the points on the circle, are the first nearest neighbors. The second ones are the second circle, okay, and they're also measured from 0, 0. The 6 first nearest neighbors to 0, 0, there are 6, okay, there are 6. The 6 first nearest neighbors to 0, 0 have coordinates 0, 1. Where is 0, 1? 0, 1 is this one. Sorry, not that one. 0, 1 is this one, because 0 should be the x, okay, that's 0, 1. 1, 0 is this one. And then 1, negative 1. 1, negative 1 is this one. That's again on the first circle, you can see. Then 0, negative 1, that's this one. Okay. And negative 1, 0. Negative 1, 0, that should be this one. Yep. and negative 1 comma negative 1 comma 1, that's this one. So you can see those are the 6 points on that first circle, and they are the first nearest neighbors. Okay, points are not always integer distances, so the distances are not always going to be integers. Okay, those the distances are not going to be integers, that's what they've said. Cool. Complete this table and show when a point is an integer distance from 0 0. Complete this table, and we need to show that when a point is an integer distance. Okay, so let's look at these points again. 1 comma 0, 1 comma 0, this is 1 comma 0, right? So this is 1 comma 0, this is 1 comma 0, and you can see that's the side of the equilateral triangle, that's unit 1, so that's an integer distance, and they've given, you know, they've checked that, and so that's an integer distance. So we just need to indicate the answer with the check point. Okay, check mark, that is negative 1 comma 1, negative 1 comma 1, negative 1 along the x, and 1 here, that one again, that's an equilateral triangle, that's side length, and remember we're measuring the distance from the origin, so that's again 1, so that again is an integer distance. Negative 1 comma 2, where's negative 1 comma 2? Negative 1 along the x, negative 1 along the x, and 2 along the y, that's the point negative 1 comma 2. Okay, from the origin, let me just erase this part. From the origin, the line joining, can you see that? So it's like that height of two equilateral triangles. Okay, so if the side is 1, if the side length of an equilateral triangle is 1, the height of an equilateral triangle is given by root 3 by 2. So when you add it up, it will be root 3 by 2 plus root 3 by 2, and that should give you just square root of 3, and which is not an integer value, right? So for that coordinate, what was that? Negative 1 comma 2, that's not an integer distance, so I'm just going to mark it here. Then 2 comma negative 2, 2 comma negative 2, so 2 along the x, negative 2 here, that's the point we're looking for. Yeah, that goes along the line, that's 1. I'm looking at that the side length. Okay, I'm just looking at the side length of the equilateral triangle, so that's 1 and that's 1, so that's 2, right? So that's an integer distance. 2 comma 2, 2 comma 2, that's here. Okay, now we're looking, remember always the distance is measured from 0 0. Okay, so we're looking at this one, all right, and so that's a root 3, that's a root 3, that is 2 root 3, and clearly not an integer distance. Okay, 0 comma negative 3, 0 comma negative 3 should be here, and that goes along the sides of that equilateral triangle, 1 2 3, so that's an integer distance. So that here we are making use of the grid. Okay, it's a triangular grid this time, so you got to make use of that and, you know, show your work that whether it's integer or not integer distance. Any comments here so far? Okay, not ever since we've asked a couple of people to leave. It's sad, but never mind, let me go on. The point A4 is an integer distance from 0 0. The point A comma 4 is an integer distance from 0 0. Write down two possible values for A. Okay, now A4 is at an integer distance, they've said. So let's look at the coordinates of the points that are at integer distance. Okay, so which are the ones? We've got this one, we've got this one, we've got this one, and we've got this one. Let's see what we can you know, tell from those things. So if 1's there, negative 1 is also there, so 1 and negative 1 and 0, that's the kind of combination. So if there's a coordinate A, then A can come with 0 or A can come with negative A. All right, that's how it's to be read. Look at this one, 2 and negative 2, all right, and 0 negative 3. So those kind of patterns are the ones which will give you an integer distance. So if A comma 4 is an integer distance from 0 0, they said what are the possible values? What two possible values for A? So we know 4 is positive, so A can either be 0 because 0 comma 4 is possible, or A can be negative 4 because negative 4 comma 4 is possible, like this point, like the coordinates of this point, 2 comma negative 2. So those are the two possible values for A, so that the coordinates A comma 4 is at an integer distance from 0 0. Okay, good evening, Philip. All right, let's move on. I was just trying to see whether there's some questions on the chat. Okay, yes, good evening. I don't know, maybe somebody just to calculate a distance on a triangular grid, the geometry of triangles is needed. Okay, they have given us the formula for the sine rule and the cosine rule. As I said, everything that you need to solve this paper, you know, is all given here. You just need to go back and forth, look at the data that's given, look at the formula that's provided, and use different approaches. Now this is coming towards the almost towards this, you know, last part of this. Yeah, so you know the difficulty level will get a little bit more, you know, complex. So let's just focus. All right, so it says this grid of points is made from equilateral triangles of side length 1. So it's just a zoomed in image of what we have seen here earlier on, okay, what we were counting. It's just zoomed in there, and they've said a triangle is drawn on the grid, so that's the triangle. The triangle's vertices are at 0, 0, so that's 0, 0, and then we got 1, comma 0, and then we got 1, comma 2, so that's 1, comma 2. Here we go, okay. It has sides of length 1, 2, and D. So this is 1 and 2 is this, okay, because this is all equilateral triangle, right? So it's just this 1 and 1, so that's 2, okay, that's how it's measured. So let me just label this triangle, maybe it'll be helpful. So again, let's call this O, A, and B, right? So this is 2, 1, 2, and they said D is a distance of 1, comma 2. This point is 1, comma 2 from origin. Okay, that's the D. Okay, so what it says, explain why the largest angle in the triangle is 120. OAB. Anyone? Anyone? Why is the angle, the largest angle, why is it 120? Put your answer in the chat. Come on. Okay, let's just keep our comments to math. Yeah, anyone? You see, this is an equilateral triangle, right? I already said that, you know, the internal angles are going to be 60 degrees. So for this other triangle out here, that's also an equilateral triangle. If that's 60, then, you know, because it's a linear pair, this one must be 120, right? So we can write that thing down and we can say that, let's just label this triangle also differently, okay? So maybe this can be C and this can be D. So you can say in triangle, what is that? CBD. CBD is an equilateral triangle. Therefore, the angle CBD must be 60 degrees. Is that right? That must be 60 degrees, okay? Therefore, we can say that the angle, the largest angle, which is OBA for the triangle under consideration, therefore, angle OBA must be 180 minus that 60, which is 120 degrees. And you can say that, okay, even as reason, you can say that it's a linear pair. Some people use the word angles in a straight line, so you can use either word. That is the largest angle, okay? So that means largest angle of triangle OBA is 120 degrees. And yes, it's just one mark. I can see that, you know, and you might be wondering why are we writing so much? Well, this paper, as I said, is a lot on communication, so you got to communicate your reasons very clearly, all right? That doesn't mean you write a lot more, you know, you need to keep it succinct also. Calculate the distance of 1, 2 from 0, 0. The distance D, you have to calculate that from 0. So therefore, we have this angle, and here we can use one of the rules that's given to us, okay? So the cosine rule is what stands out. And if you use cosine rule, we can say that the distance D must be equal to, the side lengths are, so that's D square, right? D square is 1 square plus 2 square minus 2 times 1 times 2 times cos of the angle 120. Okay, now cos of 120 is negative half. You don't have to use the calculator, but you can use the calculator if you want to. So this is just 1 plus 4 minus 4 times a half. Okay, it's a negative half, sorry, which means that will become a 2 and 2, that's a plus 2, so it is just 1 and 4 is 5 minus 2 is 3. Is that right? Let me just check. 4, that's 2, this is a plus 2, sorry, that's 7. Am I doing my math correctly? This is 2, 4 plus 2 is 6. Yeah, so this has to be a negative, which becomes a positive, okay? So that's a negative one here. Cos of 120 is a negative half, so that will become 5 plus 2 is 7. That's D square, which means D, the D should be just be equal to square root of 7. Okay? All right, the point on a triangular grid has coordinates AB, where A and B are positive integers, so that's important, positive integers. Show that its distance let me read this thing again. A point on a triangular grid has coordinates AB. A and B are positive integers. Show that its distance D from the origin is, okay, that's because it's going to be half, right? So we say D must be, D square is A square plus B square minus 2ab, and it's cos of that same 120, okay? That 120, cos of 120 is going to be negative half again, and that's going to be cancelling it out, right? So you'll get that as a square. Maybe this color is not going to be clear. There's another color, a square plus b square minus 2ab times a negative half, right? So that again, that will cancel off, and so you'll get a plus, okay? So that makes it a square plus b square, negative negative, that makes it a plus ab, and this is d square, remember? So that d is just the square root of that term, a square plus b square plus an ab. Okay, clear everyone? Sir, we can use the tan rule, inverting the axis and make the composite function of finding the distance of 1 2 from the true. But you know, I mean, there is no tan rule that's given here for us to use. Let's just use what's given, because I already said, you know, to make this really simple, perhaps, you know, just stick to what's given, and all the clues are already given. So if it's possible, if you want to use that, maybe you can enlighten a little bit more on the chat. But you know, this is enough. We don't need to make things unnecessarily complicated. Makes sense? Okay. Let's just move on to the part D. Use the formula in part C. This is the formula. See, again, they're making use of the formula, right? So if you're going to use any other rule, probably you're not going to get, you know, this thing. So, and this d square, you know, that is why we're using what is there, right? Because they want us to come to this conclusion, d is equal to, so that just comes clearly and cleanly and easily using the cosine rule, if you know what I'm talking about. So use the formula in part C, which is again this formula that we've got here, to calculate the distance of a sixth nearest neighbor from 0 0. Give your answer as a square root. Okay, so sixth nearest neighbor, what are we looking at here? So we've got, let's go back to that grid that we started off with. Okay, the first two circles are talking about the first two nearest neighbors, right? And we can see something happening here, that the first neighbor, that point, you know, this point, the triangular points I'm talking about, the vertex of the triangle, this point is here and this point is here for the first neighbor on the circle. But for the second one, it's not there. The third one is going to be this one, right? The third nearest neighbor is going to go through those 2 points. Yeah? Okay? And in that same fashion, if we go and see the pattern, okay, the fourth one is going to be, that means the even numbers, okay, 2 4 is not going to have its vertex, the triangular vertex on the along the y-axis, the tilted y-axis. Okay, it's going to be the odd one. So the first one has its, you know, the apex, if you were to call that, that's on the y-axis. The third one is going to have it here. The fifth one is going to have it here, and so the sixth one is not going to be there. Okay, so if you look at the pattern, if you just study the pattern, then when you see that, okay, here's the thing. Okay, so they've given that thing here clearly. Okay, this is the first one, this is the first neighbor, and you can see the same thing I was talking about. Okay, that pattern, this was the triangular pattern, right? Those two vertices are there, that apex is on that circumference. For the second one, it's not there. This is the third one. You can see that, you know, that point is there. This is the triangular arrangement again, okay, if you want to see that thing. And for the fourth one, it's not there. The fourth one, these are the vertices, okay, the triangular grid, the points we're talking about. Okay, and then the fifth one is here. Okay, you can see that. Okay, that's the pattern you got to follow. Okay, may I ask why people were, okay, so perhaps you're one of them. I don't know what's going on. I thought this is going to be something useful. I need to think again whether we need to do such live sessions. Okay, but anyway, let me just get back to this. If I've started something, let me finish it properly. Okay, so here we go. Let me repeat what I just said. The first nearest neighbor, okay, that the apex of that point is on the circle. Likewise, you can see for every odd number, the third one is on the circle, the fifth one is on the circle, but the even numbers, they are not on the inclined y-axis. Okay, so that means the sixth one is not going to be there. So let's look at the pattern here, how the points go, and that tells me, just looking at the pattern, this is an even number, this is the even number, this point is here, this point is here, this must be the sixth one, this is the fifth one, right? This must be the sixth one. So this point has coordinates. Let's count. This is 1, this is 2, so this is the line, this is 2, comma 2. All right, 2 comma 2. And what did they say? They said use the formula. We're using that formula to calculate the sixth nearest neighbor, okay, from 0 0. So we can use the coordinates 2 2 with that formula and say that the sixth nearest neighbor should just be sixth nearest neighbor nearest is at a distance of what's the formula? D is under root of, and we are using 2 comma 2, right? So we are using 2 square plus 2 square plus 2 times 2, which is 4. Okay, so it's 4 plus 4 plus 4, that's 12. So you can write it as under root of 12. I think they said something like leaving it as a square root. Yeah, give your answer as a square root. If you want, you can simplify it and say that's 4 times 3, which means that should just be 2 root 3. You can leave it as a square root. Okay, and you can write down using 2 comma 2. So you've indicated clearly which coordinate you've used to arrive at that 6th distance. Okay, 6th nearest neighbor. Finally, is that the final part? Yes, we are just doing the investigation. This is the final part. Use the formula, the same formula, to show that it is not possible for a nearest neighbor to be a distance of under root of 14 from 0, 0 on the triangular grid. Now you're using this formula, you're not using the grid, so no more using the grid and those points, okay? Use the formula d equals under root of a square plus b square plus ab to show that it is not possible for a nearest neighbor to be a distance of under root of 14 from 0, 0. So let's try it this way, okay? Let's try the contradictory way, all right? So let's say, we need to prove that d is not equal to root of 14, right? So he said if d is equal to under root of 14, that's the proof by contradiction, because you're using the formula, right? Then d square must be equal to 14. In other words, we are saying 14 must be equal to just that term under the square root, which is a square plus a b square plus a ab. Correct? Now, let's try and complete the square. That's the only thing I can think of. We have got these two formulae. We know that's a plus b the whole square should be equal to a square plus b square plus a 2ab, or a minus b the whole square should be equal to a square plus b square minus 2ab. Okay, let's try and see what we can do with those formulae, okay, because we just have a square plus b square plus ab. So thank you so much. All right, a plus b the whole square is a square plus b square plus 2ab, and so we've just got a plus ab here. So let's try and see what we can make out of this thing, and we can say that 14 can be equal to, we can add an ab on both sides. Okay, so either we can say 14 plus ab would be equal to, this will complete the square if you're going to add a square plus b square plus an ab, and you add ab on both sides, and we are doing that because we're trying to make use of this first formula. We can do the second one also. Okay, in fact we need to do, because we need to reason for both, right? So that means 14 plus ab, or a times b, should be equal to a plus b the whole square. All right, that's one case. Either this is possible, or if we need a negative 2ab, that means we need to subtract a 3ab on both sides. Is that right? So we'll get 14 minus 3ab would be equal, I'm just continuing from here, okay, continuing from here. So I'm just subtracting 3ab from both sides. I'll get 14 minus 3ab is equal to a square plus b square plus ab, and a minus 3ab will then give us that negative 2ab, okay, which means then the right hand side would just be a minus b the whole square. So we've got square numbers on both sides using the both cases. All right, so we've got case 1 is 14 plus ab is equal to a square number, and case 2 will be a 14 minus 3ab is a perfect square, or a square number. Okay, and this is possible only because of this assumption we made, that if d is equal to square root of 14, then we are going to end up with these two cases, and we need to disprove that. Remember, this is like proving by contradiction. Okay, so let's see, if you were to rearrange these terms, okay, we'll get 14 minus a square number would be a negative ab. Then right, just rearranging the terms. Okay, 14 minus a plus b the whole square should be a negative ab, or we'll have 14 minus that same square, different square number, that is a square number, should be 3ab. 3 times ab literally means it's a multiple of 3. Okay, here we can't say much with this, okay, but we can look at the choices for ab. All right, remember they are the coordinates, right? Remember they are coordinates, and if they are looking at coordinates, like someone had just pointed out earlier, I was confused with a particular sum that came in the 10th IGCSE. We'll do that later, okay? Right now, let's just focus on this thing, okay? We'll do that later on. A and B are coordinates, so they need to be integer values, all right? So let's look at this one. So if A is going to be, remember we need multiples of 3. Okay, that's what this left hand side should be. Okay, because 3 times AB, that should be a multiple of 3. So if A is a square number, if A minus B is a square number, then 14 minus a square number, if you even take 0 as a square number, if A minus B is 0, then 14, the first possibility you get is 14, right? If this is 0, then 14 is not a multiple of 3. Okay, so that's out. If you take 1 as a next square number, then 14 minus 1 is 13, and 13 is not a multiple of 3. Then the next square number after 1 is 4. Is that right? 14 minus 4 is going to give us 10, and that again is not a multiple of 3. The next square number after 4 is 9. 14 minus 9 is going to be, again, it's not a square number. So all this kind of discrepancy is coming. Why? Because of that assumption we made that if D is a square root of 14, and therefore we say that D cannot be the root of 14. So you cannot have, what is that? It's not possible to have a nearest neighbor to be a distance of square root of 14 from 0, 0 on a triangular grid. Okay, now I'm going to say goodbye to you all. Thank you for all who participated. Okay, if this was useful, please be sure to like, share and subscribe to this channel. I'm going to see you all next weekend.